In this podcast, we're going to discuss the discovery of the electron. So, up to this point, we have Dalton's atomic theory, and we know that atoms are these particles. Everything is made of atoms, and atoms, there are different types of atoms, and these things differ by size, by mass, by properties. So, we know that there are these little things called atoms. Now, in 1897, JJ Thomson used a cathode ray tube to deduce the presence of a negatively charged particle. We're going to see how he did this. This is a schematic of his apparatus. Basically, what a cathode ray tube is, this part in the middle, is it passes electricity through a gas that is contained at very low pressure. So right in here in this middle part is a gas. It is has a very low pressure. That's why you see this vacuum pump. You're able to decrease the pressure by evacuating molecules from here. And then you have this electricity current right here that's running through it. And we're going to see what he saw when this happened. So here's the little schematic of his setup, voltage source. When you turn the voltage source on, by running electricity basically through this gas, you see this run of almost this beam that appears to move from the negative to the positive. And so they observed this, and they thought this was this is interesting. So let's see what happens if we have a this beam running through here again, and we add an electric field around the tube. Let's see how that changes things. So here we have our electric field, and we see that we're running the beam again, and they observed this very odd motion. So seemed like the beam or the moving pieces were attracted to the positive plate. So that tells us that they are negative, because we know opposites attract. So this is very strange, right? So no matter what element they used or gas they used inside the cathode ray, they saw this same thing over and over again. And so that told them that all these elements that they're using, all the different ones, have to have these same particles in them. And they all have the same charge. So they all have these little particles, and they all have a charge on them. Well, though we all knew that just regular atoms are neutral. So that means there must have to be some positive particles inside of the atom to balance out these negative charges that we found from this cathode ray experiment. So this leads us to Thomson's atomic model. Thomson believed that electrons were kind of like plums embedded in a positively charged pudding. So he called his the plum pudding model. So over here you have a little schematic of it. So the positive is actually, the dough, if you will, and then these little electrons, they're kind of like, like little chips, like little chocolate chip cookies. They're like the little chips in there. So this is his idea of what the atom looked like. So you see we're progressing from Dalton's atomic theory, where we, basically we just know that everything is made of atoms, till now actually in Thomson's atomic model, we're getting more down to what's actually inside of the atom.